Hi everyone, this is Mr. Zirkle, and this video discusses Earth's geography and its effect on local climates. In a previous video, we discussed how solar energy influences global climate, and while it's one of the main factors influencing the climate of a particular location, it's certainly not the only one. In fact, a location's climate is influenced by both geologic factors such as altitude and mountains, but also geographic factors such as nearby bodies of water, ocean currents, and urban heat islands. Geologic factors such as mountains can affect both the temperature of a given location and the precipitation. As we learned in a previous video, the temperature of the troposphere decreases with height because the ground, which readily absorbs solar radiation, heats the troposphere directly above it by conduction and convection. So, the higher in altitude a particular location is, the colder the temperature will be. Take, for example, Grand Lake, California. It sits in the Rocky Mountains at an elevation of 8,369 feet and has an average September temperature of 69 degrees Fahrenheit. Only 30 miles away sits Boulder, Colorado. Boulder has an Boulder has an elevation of 5,300 feet and an average temperature of 79 degrees. Mountains can also affect the amount of precipitation that falls in a given location. As air travels up the slope of a mountain, it cools, condenses, and forms clouds and precipitation. This results in cloudy, wet conditions on what we call the windward side of the mountain. Windward is a term that refers to the side of the mountain facing the direction the wind is blowing. As the wind crosses the peak of the mountain, it begins to flow down the side. It sinks, compresses, and dries out. This causes dry conditions on the leeward side of the mountain. The resulting dry conditions on the leeward side are called the rain shadow effect. The rain shadow effect is evident right here in Pennsylvania. On this map, you can see two of the more mountainous regions of Pennsylvania, the Allegheny Mountains and the Allegheny Plateau. Now, if we look at the next map, which shows us precipitation in Pennsylvania, we can see dry conditions noted by yellow, oranges, and reds. These conditions correspond very well to the leeward sides of the Allegheny Mountains and the Allegheny Plateau. Large bodies of water, such as oceans, seas, and large lakes, affect the climate of an area as well. Water heats and cools more slowly than land. Therefore, in the summer, coastal regions will stay cooler, and in the winter, they will stay warmer. A more moderate climate with a smaller temperature range is created. If there are no bodies of water to moderate the climate, the same conditions follow as with vast flat plains. The climate condition is continental with more extreme temperatures and a larger temperature range. Take, for example, San Francisco, California, and Wichita, Kansas. Both are located at 37 degrees north, but San Francisco sits next to the Pacific Ocean, while Wichita lies in the center of the continent. The Pacific Ocean moderates the temperature of San Francisco. The average high temperature ranges from 58 degrees in January to 71 degrees in September. Wichita, however, in the center of the continent, is not moderated by the influence of a large body of water. The high temperature ranges from 45 degrees in January to 95 degrees in July. Ocean currents also play a factor in the climate of a location. There are two types of ocean currents, surface currents and deep currents. Surface currents are influenced by global winds, the position of the continents, and the Coriolis effect, which helps turn currents to the right in the northern hemisphere. These currents help transfer heat from the warm equator to the cooler poles. There are two types of surface currents, warm currents, which take the warm water and move it northward toward the poles, and then the cold currents, which move the water southward. These currents can have a direct effect on the climate of a location. Take, for instance, the Gulf Stream, which is shown here. It's a warm water current that moves up along the eastern seaboard of the United States. This current and its extension, the North Atlantic Drift, are responsible for bringing a moderate climate to England. Now, take a moment and look at this map of the world's surface currents. You can see several large loops called gyres, including the North Pacific Gyre here and the North Atlantic Gyre here. These gyres transport warm water from the equator northward and then back southward in one giant loop. In addition to surface currents, there are also deep water currents. These currents are influenced by temperature and salinity. As warm water surface currents move toward the poles, they begin to form ice. This increases the salinity of the remaining water. High salinity water is dense and therefore sinks, and this cold, dense current of water flows slowly along the ocean floor, where it eventually rises to the surface once more. In this diagram, you can see what we call the thermohaline circulation. You can see the orange current here, which is the surface current, flowing northward, and as it gets to the poles, it becomes dense and sinks and returns southward as a deep water current. One final factor that influences climate is something called the urban heat island effect. In a city, the dark asphalt absorbs heat more effectively than lighter colored surfaces. Additionally, concrete and buildings, once heated, retain their heat for a much longer period of time. Chemicals from industry and cars also help heat up the atmosphere. This causes what we call an urban heat island effect. What you'll find is that temperatures in cities are increased in downtown locations when compared to nearby suburban or rural areas. So, to recap, while solar energy and latitude influence climate on a global scale, other factors such as nearby mountains and large bodies of water, ocean currents, and urban heat islands can influence climate on a local scale. All right, well, that's the end of this video. If you have any questions or concerns, please message us. Otherwise, we'll see you soon.